Hello, today we are going to solve an encryption problem. So two files are given, encrypt.py and output.txt. Okay, so encrypt.py, this encrypts a flag using a reversible process, and output is it contains the encrypted data, a list of numbers as we can see here. So we are going to reverse the encryption process, and we'll try to recover the original flag. Okay. So okay, as you can see, we're here's the base 64 encoding is using here. So base 64 is a reversible encoding scheme that converts binary data into ASCII text, and the base 64 encoded flag is reversed here. This is the encryption loop, and it is using the XOR. Okay, the characters are taken from both ends and then reversed, the reversed flag, and encrypted. So this is the output, this is the encryption result of the encryption process. We are going to decrypt the encryption. Okay, so for that, start, I'm going to create a file. Let's say it's decrypt.py. we'll be needing base 64, so I'm going to import base 64 here. Okay, so as we can see in the encryption file, so this is the flag, but this portion of the flag, the first portion of the flag, this will not be changing. So this is the original form of the flag, it won't be changing. We will try to find the encryption key using this known portion of the flag, =, parenthesis. Okay. Okay, so first I'm going to write this known portion of my flag here. Let's say flag equals to that was =. Yeah, that was the known portion of the flag. Okay, the known portion of the flag is used to deduce the encryption key. Okay, so let's continue. Let's say flag equals to base 64 dot base 64. First we'll use encode. We'll be passing a flag known portion of the flag here, and we'll call encode function. Oh, sorry, it's flag dot encode. Okay, and then we will decode this part. Okay, so first encoding the known portion of the flag here to match how it is processed in the encryption script. And this flag dot encode, it converts the strings into bytes. So as base 64 will be requiring bytes. Okay, so base 64 dot b64 encode, this encodes the bytes into base 64, and dot decode converts the encoded bytes back into string for further processing. Okay, let's move on to the next step. We'll be defining a helper function. So let's say this is sol XOR. We'll be taking two parameter, num and let's say k. Okay, we'll be returning Caesar ord k here XOR num. So this helper function performs the XOR operation to reverse the encryption process. Okay, so there is two parameters, one is num and another is on k. So num is a number from the encrypted output, using the encrypted output. Okay, and the k is a character from the known base 64 encoded flag. So here, okay, k will be passing that, and the ord, this portion, this converts the character to its ASCII value, this portion. Okay, and XOR with the num, and XORing with the num, it will recover the original key character, and the CHR converts the ASCII value back to the character. Okay, so XOR is, as we know, XOR is reversible, so it makes it switchable for encryption and decryption. Okay, so we'll be writing another function called let's say it's solve solution, passing the flag, known portion of the flag, and we'll be copying the output. Okay, let's copy this and I'm going to paste it. Let's say it's output, and I'm going to paste it. Okay, key, will be extracting the key. Let's say it's empty now. Let's iterate a loop for I in range of len of flag thing here. Key will be adding, and we're calling sol XOR, and we'll pass output index, event index I into 2 plus 1. This whole thing will be inside a parenthesis, index of output. Okay, and another one is the flag value of the flag. Sorry, not the value, character from the encoded flag. Let's say it's I. Okay, the index. That's pretty much it. I'm going to return after the loop ends. Return reversing the key. So for reversing, column -1. Okay, so let's explain this. This is the output, the encrypted data, the list of numbers from the output.txt, and key. This is a string to store the recovered key that will recover here. So in the loop it iterates over each character in the known base 64 encoded flag, and this I into 2 plus 1. This index corresponds to the number from output that XORs with the flag character, and the sol XOR function, it compute the original key character. So the key is built on character at a time and reversed to match the original order. And each flag I, this corresponds to a specific XOR operation with output. Okay, so let's let's move on. We'll be recovering the flag here. So once the key is found here, the next step would be to decrypt the entire output list and rebuild the flag. Okay, this portion is only to retrieve the key. I'll retrieve the flag from using the key. Let's define a function. Let's call it flag find. So you're going to find flag. We'll be passing the key and output array or the output list. Flag equals to list. Okay, let's see string. Here's the quotation. And len would be len equal len of output, and flag len. Let's define another variable, flag len. It will be equal to output. The index of key will start from 0. Len of key will be equal to len of key. I'm going to iterate a loop here for I in range of len of output not 2 inside the loop. The flag I index is index. There will be calling sol XOR function here. I'll be sending the output the odd number, so I multiply it by 2, and the key, the index of key will start from 0. Ki, sorry, this will be ki. Oh, sorry. Now flag len minus I minus on will be equals to sol XOR output I'll be passing the even numbers 2 plus on and key klen minus k index minus 1. Okay. So if it is the end, k index equal k len minus on, it will start from 0 index 0 key equals reversing here minus on else key index will increase, will be incrementing by 1. So this whole thing will be inside the for loop. And at the end we will return flag, reversing the flag. So -1. Okay, so this is this flag, this is a list that holds the decrypted characters. Its size matches the length of output, and this flag length, this stored the length of the output for is indexing here. And ki0, so ki, this tracks the position in the key, and keylen stores the length of the key for easy indexing. And this is the decryption loop. Okay, so it iterates over half the length of the output. This is mod 2 there, because each iteration it decrypts 2. Okay, so as we were saying, this iterates over half of the output length, because it decrypts two character each time. Okay, so this is flag I. This will decrypt the first half. Decrypts a character from the front of the flag using output is I into 2 index, and current key character key of I. And the second line decrypts the another half, the last half, you can say. And this decrypts a character from the end, using this output I into 2 plus 1 and corresponding reversed key character. Okay, and this condition, this checks if the end of the key is reached. It will reset the ki to 0 and reverse the key, otherwise move to the next character in the key. And this is the reversed flag. Since the flag was reversed during encryption, it is reversed back to its original order. So now we'll be decoding the final flag. So let's say final equals dot join flag find. We'll be using a key and output. We're passing key and output. Okay, we'll fix the error in a moment. Okay, let's say then we will be doing what? We'll be using base64. We'll be using b64 decode first, then we'll pass final dot encode, and we will decode this part. Okay, we can print the final here. Okay, so let's explain these things. we'll be retrieving those things. So it will convert the list. This join function will convert the list of the decrypted characters into a single string. And the second line, base64 encoder, this decodes the base64 string to retrieve the original flag. So yeah, the output, this is inside a function, so we'll be defining this output outside the function, so we can access this. So let's say, and before that we'll be calling the function. We didn't call the last function, find flag. So flag find, this is flag find calling, and then we're passing key and output. Well, this is the same. Okay, we don't need to call the flag here, we already called it here. So the output, let's copy it from here, and I'm going to paste it there. And for the key part, okay, so there isn't any key. We'll be returning this key. Let's check the code. Okay, so this is returning the key. So the key will be here. Let's say sorry, key equals to, we're calling the solve function here and passing the flag. Okay, let's run this code. This will probably show this isn't working. Okay, wait. So yeah, here is our final flag. That's everything I need to explain. Okay, so thank you.